Well, hello there. So today we're going to be talking about programming in C and C++ concepts that are used in Arduino. So my assumption is that you took a MATLAB class here at Cal Maritime. So you've done programming and you understand things like for loops and variables and things like that in MATLAB. So converting to and from C, it's different ways to type the same thing. So the concepts you have, but you need to know the new syntax or the new way to type things. There are some differences. C requires more definitions than MATLAB. You have to plan what you're going to use. So if variables have to be defined before you can use them. In MATLAB, you can just say x equals 6, and it creates the variable if it needs to and assigns 6. In C and C++, you have to say, I want a variable named x before you can use it. You also have to define functions that you plan to use. If there are certain math functions like sine and cosine, may not automatically be used by the C compiler unless you tell it to. These are so that C can be very efficient. It can use just the amount of memory that it needs and just the functions that it needs in order to get the job done. So MATLAB trades efficiency for ease of use, and C has gone really deep on the efficiency side of things. Programming in Arduino, it's pretty much C++. It has a wrapper around it for the setup and main and other things like that, and some functions built in. A lot of the examples, though, stick really with C fundamentals, so we're going to stick with C fundamentals here for now. We'll see some C++ things like objects later, classes. Definitely use the Arduino help system. There's a really large amount of documentation out there. This lecture isn't going to cover everything. It's just to sort of tell you where to look for things. So there are really good references out there on the web, and I'll put the links on the class page too. So comments. Commenting code with MATLAB, it's the percent that comments outlines. Your code must have comments. They don't make the program work any differently, but they really are needed for readable code and reusable code and code that stands the test of time. So the standard C comment starts with a /* and then it ignores everything up until a */. You can comment out multiple lines of code with this style of comment. You can have more than one line and then end it with this. The problem with this standard C comment is you can't comment out something that already has a comment in it. Nested comments like this are not allowed. It would start the comment here and comment, and ignores this because it's a comment, and here it's going to end the comment, and then you're going to get a syntax error because it doesn't know what this means. So you can't do nested comments using this style, but you can do multiple lines. So often this is used at the beginning of a program to make a big comment block. C++ has a different style of commenting, which is the // to the end of the line. So in regular C, you begin and end. In C++ style, you /, and people mix these up and use them everywhere. So here's a comment with this /* style, and here's the C++ style comment. You can put them at the end of every line to explain how your program works. Again, the computer ignores comments, so put them in for people. So in your C program, unlike MATLAB, the end of line is ignored. So you can run a line, a statement over multiple lines or on one line, doesn't matter. You can write your functions all on one line if you want to. The line breaks, the tabs, indentation, all of that is ignored by C. The C compiler first strips out all of that stuff before it compiles things. So what the C compiler is looking for is a semicolon. That's the end of the line. So you can write a statement like this where we're defining a variable state, 56 plus 3x is big long equation, all on one line, the semicolon ending it. That's great. And there's a comment to explain it. You can break it up over multiple lines if this is easier to read. So 56 plus 3x. It keeps adding these statements together until it sees the semicolon. So exactly the same thing, different look, different style for sure. The other thing you'll see in a C program is these curly braces everywhere, where in MATLAB you would see the if statement ending with the word end. In C, it's curly braces everywhere. So a C program, you'll see curly braces and you'll see semicolons everywhere, which is a little different from MATLAB. All right, so something you will definitely not have seen in MATLAB before is the preprocessor. And this is a historical thing that a lot of programming languages have. It's back from the days of very simple text editors when you couldn't copy and paste with the mouse maybe. If you wanted to do search and replace, this preprocessor is a program that runs on your code before the compiler sees it. So it's commands to do searches and replaces. There are a lot of commands, but there are two that are very, very common, and so you have to understand those two in order to read example programs you'll find. The other ones come up from time to time, but you can Google them to see. So the preprocessor, you write your C program or your Arduino program. When you hit compile, the first thing that it does is the preprocessor runs and does search and replace. Then it takes that file and feeds it into the compiler. So the preprocessor commands always start with this symbol, which we're calling the pound sign. So preprocessor commands are always pound something. Hashtag, you might think of it as, because that's the most common use now, but please call it pound include, not hashtag include, things like that. So basically it's a fancy search and replace, as I said, and the main reasons are to reuse boilerplate code. If you have something like pi to 1,000 digits, you don't want to copy and paste that every time. You can use the preprocessor to insert that in your code, and also to define things, make definitions that might change, like specifications or parameters or the processor you're using or something like that. You can define them up at the top and then change them in one place and have the whole program get updated. So it's a search and replace. Pound include is the first really common one. When you see pound include, that means it's going to find a file that matches whatever comes after that. So pound include liquidcrystal.h. It's going to look for a file called liquidcrystal.h. It's going to delete this line and paste that file right there. So it inserts the entire file. If the file name is between the less than and greater than symbols, that means it's built into the C compiler's library. It should be installed where the compiler already has a lot of things. So things like sine and cosine don't naturally occur in C unless you pound include math.h here. The Arduino does that for you. That's one of the things that's wrapped around though. So you can use sine and cosine in Arduino. But a lot of Arduino libraries, this Liquid Crystal is an Arduino library that works to drive LCD displays. So if you want to use libraries, you always have to include a pound include line of code. You can use this for anything if you want to define pi to 100 digits, like I said, or if you want some other lookup table or some big block of text for your web page, you can use pound include. You put the file name in quotes and it will look in your local directory for that file. So this is a way to have stuff to be reused and included into your code. Usually they have a .h. It's not required, but that's the standard H for header files, because usually you would put these at the top of your program so everyone can see it's not this code, but I have to add that. So pound include you'll definitely see because it's how the libraries get added. The other one is pound define, and this one is a direct search and replace within your code. So pound define, and then there are always two words, two things separated with a space, and pound define this, that, tells the preprocessor that before we compile it, we find every this, THIS, in the code, and we delete it and replace it with that. So this would be a terrible, terrible thing to do in your program because it would make it really hard to read. this example, this first example. Where this is useful is something like this, where maybe we want to set arrays, how much storage we need, or what voltages are important, or something like that in our system, and maybe that changes the next time we use it. So at the top of our program, we can say pound define max 100, and everywhere we use max, it's going to search and replace 100. If we decide 200 is what we need, we change it in this one place, and it fixes the entire code. You could do some of this with variables, but this actually doesn't take any storage. It doesn't have to get fetched from memory. It literally types it into your code, so it's sometimes a little more efficient from memory usage. And it's very standard for defining configuration parameters. So pound include, pound define, you'll probably see. There are other things like pound if and things like that, but they're a little less common. And that's the preprocessor. Okay, I mentioned that you have to declare variables because C wants to be efficient with the way it uses memory. So you have to tell it in advance what variables you want to store and what their names are. And in order to be efficient, it also has you say what kind of number you want to store so that it can use the smallest amount of memory possible to store the variables. So that means there are a lot of different kinds of variables that you have to decide yourself what you want to use. So there are whole number variables. Char is short for character. It's an 8-bit number, because ASCII characters, that when you're typing, it's stored on the computer normally as an 8-bit number. So it can be any number. It's a whole number. But on the Arduino, it's an 8-bit number. So an unsigned char can count from 0 to 255, if you remember how binary numbers work. 2 to the 8 minus 1 would be the biggest number, 8-bit number that you can store. It would be 8 ones in a row is 255. Signed char uses 2's complement to store an 8-bit number, so it can count from negative 128 to 127. So this is the range for a signed char. So use these for things that don't count very high, because if you try to store 300 in an 8-bit number, it'll overflow and it'll store the wrong number. Int is another whole number variable type. It's 16 bits on Arduinos. These are set to different types depending on the computer you're programming. So if you're programming on a 64-bit computer, int is probably 64 bits. And you have to know something about the compiler. But on Arduinos that we're talking about, int is a 16-bit number, so it can count 2 to the 16 minus 1. So that's a bigger number. And it's a whole number, no decimal points here. Float is a floating point number, so it does have the decimal point, like 3.14, or scientific notation you can use here, 2.3 e to the 4, 2.3 10 to the 4 is what this means. So most of the engineering calculations are done with floating point numbers. It takes 32 bits to store a floating point number on an Arduino, and it's stored sort of in scientific notation, but in binary. If you need more decimal points, you can't really say exactly how many decimal points, because again, it's in binary. But if you need more, lots of precision, less round-off error, use the double. That's going to really slow your program down and use a lot of memory. So don't use this unless you need to. But double will give you more precision. MATLAB does everything in double precision by default, because it doesn't care about efficiency. Long int, or just long, is a bigger number than an integer. So if you have to store a big whole number, you can use long. Like I said, on different computers, these might be different sized. They're all sort of relative to each other, but there should be a file called limits.h that declares how big a number you can store in all of these different types. So if you really need to know, that's how you can officially find out. Functions, we've already looked a little bit at C functions, because there's always the setup function and the loop function as part of Arduino. But functions, you also use functions like sine and cosine, where they take an input, they return an output. They're like a black box. You don't know how a sine function works, right? You just give it the angle and it gives you the sine of the angle. Does it do a lookup table? Does it use a series solution? Nobody knows. Somebody knows, but we don't have to know. And that's the great thing about a function. They isolate that calculation. So they're optional, but it's good programming style to make your code modular and reusable. In C and C++, a function can only return a single variable. So MATLAB functions, you can have more than one thing come out of the function. But in C, it can only return one number, like sine and cosine. They only return one number. Square root returns one number. So C only is limited to that. If you need more than one output, then you can use a single variable that holds more than one output, like a data structure with it, which is a C, or a class object in C++. And we'll see that in lectures farther down the line. So it is possible, but you return one thing that holds several things, arrays. So in C function, this image is from the Arduino reference, which is a useful place to look at this. This is what returns. So this is a function that's going to result in an integer. So you have to give it a variable type, give it the name, and then you have to declare the inputs and the input variable types. So this returns an integer. It has an input integer named x and an input integer named y. Then we have variables and code inside these curly brackets. So this is declaring a variable named result. It's an integer, so a whole number. Then here's code that actually calculates result equals x times y. And then this word return says to take this and send it out, the code. So we can take this function and we can stick it at the top of our C code, and then in some other function we can call the function. So here is a loop function calling the function that we define up here. We say my multiply function, we give it two numbers that are integers, and it multiplies them together, sends that back. That answer gets stored in K. So this result is an intermediate value. We don't see that name showing up in the main function. Result gets passed to loop, and loop copies it into K, and off we go. So this looks like when we call sine and cosine and lots of other functions that you're used to using, but you can write your own here. We're going to be writing a lot of functions in this class. I think it's good to have a good programming style, so we'll be using functions in the mechatronics class. Okay, so we talked about variable types, char and int and float and that kind of thing. But this is talking about variable scope, where variables are declared and what that means in terms of where they can be used. So you have to declare variables. You can declare them as global if you declare them outside of all of the functions. So here are some declarations. If this isn't inside the curly brackets that define a function, these would be global variables. Usually at the top, not required though. If they're global variables, then all the functions, setup, loop, anything else you use, can see the global variables. Local variables are declared inside a function. So if you declare it inside the curly brackets that define a function, then it's a local variable, and this is a good programming style. It's isolated, so if you want to name a variable named x, you can use x in all of your functions, and they won't write over each other. Other functions can't accidentally mess up your values because they're not shared. So this keeps it inside its own little sandbox inside of the function. So whether you use global or local is definitely a programming style thing. Most modern programming styles use a lot of local variables and really frown on using global variables just because it's hard to keep track of global variables and it's not as portable and reusable if you have your declarations outside of the functions. But for things like microcontrollers that don't have very much memory, global is sometimes a nice way to go, because if you have local variables, you have to have different copies and things get passed around, and it can use a little bit more memory. So our Arduinos have very little memory, so it's actually okay programming style to use global variables on memory constrained processors like Arduinos. So here's some examples of a program using both global and local variables. So again, we have the setup function and the loop function are part of our Arduino. We have to have those two functions in order to have an Arduino program. And here at the top, we've declared an integer, a whole number, 16 bits, named push button, and we can actually initialize it to have a value of 2. So this is a global variable. We want this to be a global variable because we're using it here in the setup function. We need it as an input to the pin mode function, that's an Arduino function, and we're using it down here in the loop function. So if we didn't declare this as global, we'd have to somehow make it available to both of these. So global solves that problem. Down here in the loop, we have a variable declaration, and so this is inside the curly brackets of the loop. So we have a local variable named button state. That's a good place to use a local variable because it's only used to store this measurement that it takes, and then we print it out, and then we don't need it anymore. So it keeps it local. Nobody else needs to see button state, so it's a good style to keep local variables. But again, it's your choice whether to do everything in global. That's simple, doesn't use as much memory, but not as modular, so you'll have to make a decision.